So welcome everyone to the latest AWS South Wales user group. So today we're going to be delighted to give a talk around using AWS to grow an AI startup. So we're going to welcome Aled Jones from Selligence. And then, we're well into pre-invent season now. So we'll start seeing lots more updates about new features and new services for the major conference, so reInvent starting next week. We're also delighted that Mobilize Cloud, so an AWS consulting partner, they're our sponsor. And they've very kindly agreed to give away some exam vouchers for an AWS exam of your choice. So keep listening, and we'll welcome in Jim Carney towards the end. So first off, I'm going to welcome Aled Selligence. So today you're going to talk about using AWS to grow an AI startup. So I'll leave it over to you now to give an intro and give your talk.
Thanks a lot. Thank you everyone for having me, and it's great to be presenting to you all today. So the agenda of today will be, first of all, who I am and who are Selligence and what we do. I'll then move to what we do at Selligence and the products and the use cases. Following that, I'll give a high-level overview of how we achieve our product goals. And to achieve our goals, we make extensive use of AWS, and I'll show you some of the use cases and show you what we've been doing, and hopefully that'll lead to some questions at the end that I'll hopefully be able to answer. And yeah, so we'll make a start. So who am I? So my name's Aled Jones. I'm originally from North Wales, so excuse the accent, or if I randomly say Welsh words mid-sentence. I went to Cardiff University, then more or less stayed here. I've worked in software ever since. Most of my formative years were working at Nagra Pinkham Bran when I left there as head of system architecture. Despite the White Tower position, my title provides I'm still an engineer by heart. I love to get stuck into the implementation side of things when I can. I joined Selligence in early 2018. Back then, it was called Talentica. So we actually recently renamed our company to Selligence after we kind of built a bunch of different products, and Talentica was one of those. So it made no sense to kind of keep the name of the product as the name of the company. I joined Selligence in early 2018 after a great pitch by our CEO, Nick, who persuaded me to join despite my initial trepidation about joining a startup. Always scary when you've been, established in the comfort of a much bigger company, but being able to build something kind of truly exciting from the ground up using technologies such as, AWS and some of that cloud native services was too great an opportunity to miss. So here I am, over 3 years later, and going to talk to you a bit about what we do. So a bit more about Selligence then. So as I said, Selligence Technologies is now the name of the company, formerly Talentica. So we build HR and sales software as a service. So basically, we build AI-driven use case systems. So we provide market intelligence, talent sourcing solutions, and now more recently, automated candidate onboarding. So the company, as I mentioned, was founded by Nick Vaughan, a serial entrepreneur with several companies in his background. As I mentioned, the original solution is called Talentica, but we've since released a product called Anaxim, which is more geared towards sales. Talentica and Anaxim are market intelligence for recruitment and sales, respectively. And now in Talentica, we also provide sourcing tooling. Lamplight, meanwhile, is a new initiative focused on automated candidate onboarding, with the first focus being on contract nurses in Florida. I won't go into that too much today, but it does share the same stack and some of the same tooling as the rest of our products. It's been quite the journey to see us grow from a team of a literal handful of people. I think there was maybe 4 or 5 people in the tech team when I joined, to around 70 total staff of 60 to 70 total staff. It's hard to keep count because I think 5 joined even last Monday. But yeah, it's been a great journey. So what does Talentica do? So Our main feature focus has been to provide market intelligence information to our customers. So we gather information from business news sources, identify and predict market triggers that a recruitment or sales professional can use to help improve the efficiency of the business development, essentially. So, the great example is a recruiter or a sales professional will typically spend like 40% of their day looking for new work. The rest of the day might be spent calling, prospective customers or talking to existing customers. But, a good deal of that is spent looking for the next job. So essentially what we do is if a recruiter sees a curated news that should result in hiring or a prediction of change within a company or a people move, for example, the idea is that it makes more sense for them to focus on trying to sell their services to that company rather than others that essentially might not be active. So essentially by providing those triggers to recruiters and sales professionals, they can more effectively spend most of the day doing what they do best, which is selling. A lot of us might find the processes that recruiters, talent managers, and salespeople follow a bit frustrating, but a bit like targeted advertising. Having that relevant communication to yourself is better than receiving wild random cold calls from people. So our predictions can mean that our customers can have an edge in identifying new business sources. So we'll talk a little bit about the how. First of all, I'll look at our predictive market intelligence. So how does Talent Seeker generate market intelligence? So in a nutshell, we mine the internet essentially and various other data sources for news articles and other data points 24/7. This data is then filtered to relevant information. So we don't particularly care about the sports or perhaps politics and so forth. Interesting as it is, but not as relevant for market intelligence. And this data is then filtered to relevant, is then processed and annotated using a library of AI models. We then further enrich and validate this data using a database of company location and people data. So this data is also updated 24/7 using multiple different sources. For example, I'm not sure if you heard of some of these companies, but Clearbit, Cognism, Google Places, multiple different data sources that we use to kind of aggregate and gather together information about those things. Finally, our AI decides to either publish content about these events, either directly to customers or push to our research team for review if it's not confident in its analysis. So we have a team of, I think, close to 20 researchers today. So they are, their job is essentially to publish and label data for our AI training. So that research feedback helps train our AI models to improve the accuracy of our natural language processing and predictive and other predictive models. We also have a similar pipeline for vacancies. So again, we try to publish vacancies about, that people are interested in, that again, searchable and filterable. The challenge there is a little bit less than our news processing, simply because the vacancies are already tagged to some extent, but still an interesting challenge in terms of volume and making sure we kind of map data to the right things. So the other main feature that we focused on is a relatively new feature for Zelligence, having just released that this year. So we realized that all of this data that we were collecting could fulfill our customers' needs for talent. And actually, post-COVID, during COVID, our tool was very suitable. People for looking for jobs, there weren't that many jobs available. But since COVID, we've all seen a kind of bounce back of the industry, especially in industries like in IT. So we realized that our data could fulfill our customers' need for talent. That was quickly becoming a huge priority. So we quickly then worked on this solution. So our talent sourcing solution has access to over 500 million contacts, or over 500 million contacts, sorry. So allowing our customers to kind of quickly search for and find potential talent by numerous filters, including location, roles, industries, experience, for example. And we've recently introduced some of our own AI magic to that solution. So, giving a bit of an edge over some of the other products that are out there, introducing new things such as predictions on, and how open a person might be to new opportunities if they were potentially looking to move on from the current role. So next, I'll talk about how we do that talent sourcing. So the challenge with talent sourcing is the amount and complexity of data. So managing over 500 million complex records with multiple sources of data, which don't always align. In the picture, I've shown an example of various pictures of myself just to kind of represent different example profiles that may relate to me. So for example, one source might only have my employment history as of my last position, whereas another might be completely correct. So it might be, Alec Jones, that's Allegiance, everything aligns. So how do we identify the two profiles are the same? How do we merge them? How do we check for differences? All of this introduces complexity to what is essentially data management problem. But fortunately, we were able to build a solution in only a couple of months using AWS, which including making use of a monthly file-based provider providing terabytes of data each month. So by making use of some of those cloud-native services, we've been able to pull some of those features off much more quickly than we otherwise would have. So some additional considerations before we move into a view of AWS and how we use it. And to some extent, why we used AWS, and in some cases where we didn't. So as a startup, you're reliant on a small number of individuals, essentially. As I mentioned, I think when I started, there was 3 or 4 people in the tech team, including myself. You don't have large teams, distributed teams, all specialists in various different things. So, each individual is hopefully a jack of all trades, but obviously can't be a master of everything. So we can't have too much complexity in a lot of different places. Otherwise, a small team won't be able to manage that. So ease of use and reusability of design patterns was therefore kind of really, really important. Cost is also obviously a factor. Startups typically don't have vast amounts of capital. Can't just build an amazing overarching architecture that does everything with hundreds of servers and so forth. So with the expectation of hopefully making money in the future and some obvious risk in, it's a startup, there's obviously some element of risk, as with any company to be fair, but maybe a little bit more in a startup. So upfront costs were not something we could or were willing to kind of stomach. So the pay as you go model of AWS, to the minute or to the hour, to the second, or I think in Lambda millisecond was massively beneficial for us. So we could, start off with simple use cases, start off very low cost and grow from there. As a technology leader, build versus buy is always at the forefront of your mind. So the dry principle of, or do not repeat yourself principle, ideally applies to your own code, but also to some of the open source libraries, as well as some kind of commercial products that are out there. No one wants to rebuild Excel. There's a perfectly great Excel out there. There's no point in rewriting it. If there's a service that does exactly what you want and does it very well at a reasonable price, make the most of it. Especially if it's free, even better. But you don't want to go and build anything that doesn't provide specific value, based on what you're trying to build. So we want to be able to focus on building out features that bring value to our customers rather than build and maintain common use case stuff like payments and maybe authentication and so forth. And finally, on this point, the reactive manifesto. I don't know if any of you have seen it, have read it. I was looking it up yesterday after I think someone commented on LinkedIn something about it, and I realized that I'd actually signed it twice in the last, I think, 10 years. I think there's a version 2, which is why I signed it again. But I think, I encourage you to read it. Even if maybe you don't agree, but I think, personally, I feel that building systems that are responsive, resilient, elastic, and message driven from day one are pretty critical for any business, especially if you can't realistically plan on how and when you will scale. Every startup dreams of gaining traction. and massive amount of users, but you never know, when you're going to have to go from very little users to a very high amount of users, or similarly with content, when you go into very little content to very high amount of content or other types of data. But you need to be ready for it, but at the same time, you don't want to be spending on things you're not using. So if you don't have a very large amount of users, you don't want to be spending on services for a large amount of users. So AWS and its serverless services makes it pretty easy to build reactive systems, and I'll talk about that next. So AWS. So our use of AWS was driven by those considerations I just covered. As a very small team that needed to build, maintain, and monitor the features, we wanted to minimize risks and operational staff costs. Very little people, don't have lots of money, so we essentially made the decision to be as serverless as possible. We didn't have the resources available to build kind of complex systems of our own. I wanted to avoid the potential pain points of having to look after physical or virtual servers, unless we had to. So what this ultimately meant is we made use of Lambdas wherever possible, and containers on Fargate, for example, where Lambdas were perhaps too small or too short-lived. So I know Lambda especially and a lot of other database services have evolved massively even from 3 years ago when we started. But certainly, we're reasonably proficient even back then. We decided to use Terraform to define our network-based components like we've subsequently used the serverless framework, which, if you're not using it, I encourage you to do so unless you've got a great reason not to. Makes it so much easier to manage all of our kind of serverless-based projects. It's very easy, very quick, and it's meant we were able to kind of deploy, new functionality in minutes or hours, rather than have to think too much about, where it all sits and where it all lives. Using the serverless framework meant that we could configure and deploy CloudFormation stacks that include Lambda function quickly and easily. Lambdas mean we don't have to worry about scaling up or down as we gain or potentially lose users. So again, our customers typically use our products at certain times of day. It's very much a business tool. It's not going to be largely used on the weekend. It's not going to be largely used outside of office hours unless someone's burning the midnight oil. So the usage patterns of our platform is very especially on the front end APIs, which serve the users, is very kind of bursty, shall we say. So having a system that is able to scale instantly and elastically has been great. We've also made use of Lambda layers, which allows us to share like common functionality across multiple projects. So layers, I think, was something that came out, I think it was in reInvent 2018, and it's been really useful for us. So we have a repository. We are a Python, I haven't said it before, we are a Python-backed or server-side company with JavaScript or TypeScript on the front end. So we have a common set of libraries on a PyPy server that could be used by some of the containers and so forth. But having that layer there that was used across multiple different things meant that we could keep the code against each feature really small and tight as much as possible. So that's made it again much quicker to quickly build features as we need to. We decided to use Fargate. I think I mentioned that before, for the same reason as Lambda. So Fargate is AWS's serverless container solution. You define tasks that indicate the type and size of container. Your container image, and essentially AWS takes care of the rest. You don't have to think about clusters, about potentially a Kubernetes cluster or an ECS EC2 cluster. You just tell Amazon to run your container, and there we go. Again, it's all about reducing the complexity and the operational headaches and costs. That essentially a small team can hardly stomach. Want to focus on building these features. So even though Fargate, technically is higher running costs than perhaps a well-built Kubernetes cluster or an EC2 cluster with perhaps reserved instances or spot instances would have, the cost of building and deploying all of that would have, at least originally, far exceeded the running costs that we had. Back in 2018, I think Lambdas were typically a lot smaller than they can be now. I think there was maybe a 5-minute, max runtime. I think there was like 1 gig of RAM perhaps, and maybe 1 CPU. I know they've like massively increased the abilities now. I think it's now like 10 gig of RAM, 50 minutes. But still, it's some of our, especially our AI models are quite complex, fairly RAM hungry and quite large in terms of storage. So we do use containers, a fair bit as well to this day. As I mentioned in the previous slide, we wanted to build a message-driven platform as they're ultimately more flexible, loosely coupled and scalable. Having implemented, messaging systems in the past and reviewed what was available at the time, and to this day, really on AWS, we decided to opt for a combination of SNS and SQS, which AWS's simple notification system and simple queue system to implement essentially what is a pub sub platform. I'll come to some example scenarios of that in a few slides time. But we essentially reused that design pattern extensively across our platform, either to carry data around the platform or just to, as an event bus design pattern where you're basically notifying other systems of things that have happened, essentially, again, to be as reactive as possible, to be able to respond to the users as quickly as possible. I won't go into much detail on some of the other services that we use. But having said that, as a user facing software as a service websites, the customers can access a website, can use it. So tools like OpenSearch, which was until very recently called AWS Elasticsearch, has been great. Allowing users to implement, allowing us to implement complex queries across, lots of data, including free text search, multiple filters, and even geo-based filters, so you can like search for people around Cardiff, within 20 miles of Cardiff or things like that. Although not serverless, AWS's infra management has been pretty straightforward with OpenSearch. So even though, again, it's not completely taken care of, not everything's taken care of you, but, upgrading and managing those clusters has been fairly painless for the most part. So, being able to shrink or enlarge clusters has been pretty easy. We use Postgres for our analytics. As I'll come on to the next slide, it's not a main database and main contact database. I know it's a popular relational database for a lot of companies, but it's not a main database, but we use it for analytics, and it's been great for powering our BI tools and reports. S3 is obviously a no-brainer as a data store for everything. So, I think no surprise we use that. We also use it, again, maybe no-brainer as a data lake for, for the content, and we are processing and importing. As I mentioned earlier, although we'd ultimately like to use, to avoid using EC2s, at least certainly originally when the team was quite small, where possible, again, due to the management and time costs, we do use them ad hoc for various use cases, such as running scripts or anything ad hoc, AI model training. And we actually don't use SageMaker for that, but we do run our AI model training on quite beefy kind of graphics-based systems and so forth. Redis and Dynamo, some light use. Redis is obviously mostly used for caching and should be fairly self-explanatory. DynamoDB we have used, we still use to some limited extent, but again, it's all about the ease of use, the complexity, what you're trying to achieve. And we did find DynamoDB in a lot of cases is a little bit complex or didn't quite fit all of the types of querying capabilities that we ultimately needed. So what do we not do with AWS then? Well, obviously, any company, you can't put everything on, on the same platform. AWS doesn't do everything, doesn't provide everything, doesn't provide any solutions. So especially when it comes to software as service solutions. So MongoDB has been our main content store database to the nature of the data we store. So as I mentioned earlier, we store lots of news article information, people, company information. These are all kind of essentially document-based records that, in various different use cases can either be small or large, or, have varying fields and varying types of content. So, the flexibility of MongoDB has been great for that. Mongo Atlas specifically provides the, again, easy management, monitoring tools and support that we thought we needed for what was essentially our main database at a quite a reasonable price. So ultimately won out against things like AWS's own DocumentDB. It's still, of course, hosted by Mongo and AWS, and we VPC peer that to our own VPC, to make sure we don't incur any kind of bandwidth or exchange costs, and it keeps it well integrated with our main platform. Vercel is, for those that potentially interested, is a platform as a service for our front end. So for those of you that may be like front end engineers, which I apologize is not my expertise, but it's ultimately a Jamstack platform using Next.js that in the back end I think runs on AWS. Originally we deployed Next.js as a framework, as a solution, using serverless on our own AWS infrastructure, but the platform that Vercel have provided has reduced the management costs while having a reasonable operational costs overall. So we ultimately opted to move across to Vercel. I'm not going to go into all of them. You can kind of peruse what some of them are at your leisure. But just to add that Auth0 is a great example of a service that essentially, especially at the beginning, was a no-brainer to use just because it was so cheap. I think it was something like $13 a month for an end-to-end authentication system. We did look at Cognito, but again, some of these services don't provide everything you want in terms of things like admin tools and support and so forth. So again, buy versus build. Sometimes it just makes sense to pay for the service that provides a great value and use it. So for this slide, I'm going to talk about some of the use cases. So again, I mentioned, we use the serverless framework with Lambda for essentially ultimately, I think all our APIs are backed by Lambda and deployed with the serverless framework. So ultimately, I'm sure some of you are familiar with how that looks, but you have, in our case, we use CloudFront in front of CloudFront for the reverse proxy and DNS capabilities. We need DNS for other platforms, not just Amazon. So Cloudflare makes that really easy, and again, very cheap. So for serverless, as you can see in that example I've got on the slide, that's an example definition of a service with a couple of plugins. I think one is to use a requirements file to import some of the required libraries. Another one is for pruning old versions, so you can essentially extend functionality of your deployment by adding additional plugins. I know we have some that, for example, keep Lambdas warm. So those of you familiar with Lambda, they typically go cold after a certain amount of time, so need a little bit more time to warm up. With some of these plugins, you can keep them, essentially it forces CloudWatch to ping or keep the Lambda warm every 5 minutes, just to make sure there's at least one Lambda ready to respond to any user request. So some considerations with this is, as I mentioned, make use of warm Lambdas on your APIs that are very busy, just in case you get like a period of little activity on a website. There's nothing worse than a user arriving on your site and they hit an endpoint, or they hit an element on the site that triggers an endpoint that then takes 5 seconds to wake up. So they think, oh, what's wrong with this website? But it's just the Lambda waking up. So make the most of that if you can. Use Redis as a cache, potentially when shared resources are required. So You can make the most of some of the warm Lambda in-memory caching, but sometimes that's not sufficient. So something like Redis in front of a DB can be useful. Consider edge lambdas for some use cases. I know Vercel uses this built in and does it for us, but certainly if you've got client-facing lambdas that are doing things around generating elements of the website, then having edge lambdas means that specifically in things like Jamstack applications, those responses can get back to the user much faster, especially if they're some of our users are based out in, for example, in the West Coast, which is reasonably far from our main data center. We deploy stuff in EU West 1, which is in Ireland. So again, edge lambdas can make a difference there. So we wanted to talk a little bit about our use of SNS and SQS as a pub/sys system, as I mentioned in a previous slide. So our article pipeline actually uses this mechanism to transfer articles through multiple stages of AI and human processing. So the example of image, hope that's reasonably clear for everyone. Example image shows a simplified view of just what would be like the first stage of our pipeline. So a pipeline, as mentioned, is lengthy and there's several different processes involved, which kind of deal with articles and vacancies as they come in. So in this example specifically then, so we first source articles, as can be seen on the bottom left, using Lambda or container-based, essentially mining, as we call it, agents dedicated to gathering articles from that data source. So things like Twitter, RSS feeds, crawling the web. Some, as I mentioned, we've got some data providers that we integrate via APIs. They're then able to immediately publish those articles as messages on SNS. So fortunately for us, SNS and SQS have a max payload size that is sufficiently large for most articles. I think we can back them up with S3 if required, but does mean that we can float these articles in full around the system. The SNS is then essentially, if you're familiar with pub subsystems, is a topic that any number of subscribers can then receive, be that an SQS queue or something like an email platform or so forth. So in our case, for example, there's an articles queue, essentially. The first queue is all the articles. So all of the agents publish their messages to the same SNS that's get subscribed to an all articles queue, which is in turn consumed by the first stage of a platform, which in our case is a filter. So as you might expect with a article or news article based platform, we do get news that is, as I mentioned before, I think not interesting or not relevant. There's all kinds of stuff on the internet, and we can't be too clever about what we try and scrape or retrieve. Otherwise, we might risk losing stuff. So better to just grab everything we can and filter it later. So that a filter essentially reads from that whole articles queue and processes the articles and then pushes them on from there, depending on them being a good article or a bad article. And as you can see in the pipeline, you can essentially have what is similar to essentially a state diagram in your head or an activity diagram, whereby the articles follow different paths depending on the outcomes of different agents that form part of the pipeline. So some of the characteristics and functionality of SQS does provide added value to this type of deployment. So as part of SQS's default behavior, a dead letter queue is available where messages, or in our case articles, are put if they fail to get processed properly. So if a bunch of articles go through fine and then suddenly for whatever reason, maybe there's an article with a weird character in it, or just for whatever reason the agent is unable to process it, then those messages can be put on a dead letter queue. We can then monitor that queue and see what's on there and retrieve them, and if need be, either fix the problem, redrive them through, or whatever we need to do to progress those forwards. The nature of our data and this essentially means that each article is fairly distinct. what it does mean is then we're able to we don't care too much about the order and the speed to some extent of how fast these the data is coming through. We don't need to care about the end-to-end speed or throughput. As long as we're dealing with all of these messages, articles in a reasonable amount of time, then it's all good. The design pattern we've got here essentially allows us to fine-tune the consumption behavior of our system as well. So if messages are sporadic, for example, we might decide to only periodically consume data from the queue in order to save some costs. So what that actually means, for example, is if we didn't get that many messages for the container to be, to need to be on full time in order to process all of them, then perhaps we can actually switch it off for periods of time and then turn it on where it grabs more messages, processes them, and then goes back to sleep. So we can save some substantial costs if we kind of clever on how we consume and how quickly and so forth. On the other hand, if we get massive volumes, then again we can scale out the cluster of the number of containers and number of lambdas that are there in order to process messages faster. Another example is potentially, when you're writing to maybe a data lake and there's no need to kind of write to the data lake in real time or onto a database, for example, then you can actually use the queue as a way to batch all of that data and then maybe use the bulk write facilities of whatever database or S3 storage or whatever you're using, just to, again, gain some efficiency there. We didn't have to use SNS for this workload to work, but using it allows us to dynamically add consumers as we need to. So if you see like in the top right, I haven't put any detail there, but you could see a use case where we've got this topic that is pushing articles from whatever AI task 2 is, and then we decide, we actually want an additional recipient of that. It's simply a case of adding a new queue and subscribing it to the existing SNS topic. We don't need to recode or redeploy anything additional or change the existing kind of agents that are out there. We can just leave them as is and plug in essentially new parts of the pipeline. This pipeline pattern also means we don't have to impact the databases if we don't need to until all stages of the pipeline are complete. So it might not be a concern, but in this example, we're actually not involving our end results databases until the end. We don't, for example, if there are articles that have been filtered out, they're not interesting, then there's no reason for them to go to our database at all. So we can just process it all using these various agents and queues, and then put them straight into the barred article bin or data lake as we have here. It also means we don't lose any messages. If data fails to get processed by a consumer, either due to an error with the content or the consumer itself, the queue can be configured to keep the messages until the consumer is ready. This has saved us so many times where we've suddenly noticed that the number of articles or messages at a certain point in the pipeline is started to increase. It triggers an alert, and we suddenly realize, someone deployed something that didn't actually work quite as intended, perhaps, or there's some other issue, and in some other solutions maybe would have lost messages that we weren't able to process, but in this case they just like pool together until we're able to get around to fixing that issue. And as I mentioned before, this pipeline type architecture maps quite well to a kind of a state diagram. So as an architect, it always helps when the idea or the chart or the diagram you have in your head actually maps quite well to what you're building. Just some additional notes on some of those kind of options then, or that kind of pipeline architecture. So bear in mind that with SNS, you've got cross-region delivery. So in one of the use cases, we're actually moving data from one region to another without incurring some of the kind of bandwidth, the costs that other solutions might require. So we've got a solution whereby we're reading data from a specific provider that puts all data in S3 bucket in Virginia, and we can then parse out the bits we need, send the articles over SNS, and then they're subscribed to in the island region as normal. I mentioned dead letter queues already, so can either redrive or reroute failed messages. So, as long as you're monitoring the dead letter queue for failures, you can kind of pick them up, when you need to, and decide what to do with them. Either if you fix the issue, push them back through the same queue, or you can, potentially have a different queue or different pipeline entirely for those types of messages. Do check the message retention period. So I think in our case, it's maybe a little bit longer than default, which I think is 4 days. So give yourself enough time to fix. But obviously, ultimately, if a message gets too stale, then maybe it's no longer relevant. I think there's a max timeout of 2 weeks. Use content ID based deduplication if it's applicable. So it's not directly applicable in our case on this one, unless we potentially hash the URL, I guess, of some of our sources. But in some of the other use cases we have, then that content, it can be hard to track. Oops, I'm going back. It can be hard to track, what content you've put on an event bus or something, or what you've already done. So having some of that content-based deduplication, especially on non-real-time pipelines, is very useful. First in, first out is, I think, a relatively new aspect of SQS, which might make sense for you if the order of message is important. In our case, the order, because the content is fairly distinct, the order is typically not relevant or not important. But from my experience, it's usually fairly first in, first out anyway. But there's no guarantees. So as part of our pipeline and event bus kind of pattern in general, we do make extensive use of Lambda triggers, which I believe kind of came out in maybe 2019, and I know it wasn't available when we originally built the platform, and we had to use long polling. To talk a bit about Lambda triggers specifically. So just to make sure that each Lambda that is going to be triggered by an SQS queue is able to handle multiple messages at once. We did have a use case whereby, for some reason, a specific Lambda had been essentially coded to only deal with the first messages for the first message. And unfortunately, that is a case where you can lose messages. But as long as a Lambda is built to deal with a list, essentially, then it's all going to be good. The batch window, maximum batching window. So these relate to how long to wait before dealing with pooled messages, and then essentially the max number of messages before a Lambda is spawned. So default behavior of Lambdas, and it's probably relevant to APIs, user-facing APIs, is that essentially they react immediately, and if there is concurrency in terms of how an API is used, then it will just spawn more and more Lambdas to fulfill the need, which is great. Elastically scales, and all of the users are happy. But for things like content and data processing is not always the most optimal solution, especially from a cost perspective. So by using things like batch window and maximum batching window, you can kind of force, I guess, the Lambda to deal with multiple messages and to wait until you have a reasonable amount of messages before trying to process them. And again, as I mentioned before, some of the kind of warm and cold Lambda issues, if you're spawning loads of cold Lambdas, then it's going to be more expensive than having a lower number of warm Lambdas, process more messages. So play around with values that make sense depending on the urgency of the problem, the cost efficiency, and the ability of the single Lambda to deal with multiple messages. So for example, if it's going to take 15 minutes to deal with just a handful of messages, then that maximum batching window needs to be fairly small. But it's something to figure out depending on the use case and the message. One other thing we've kind of done a bit more recently, what to talk about, was some of the kind of ETL stuff we've done with Lambda. I'm not saying this is the best solution or the best approach, but again, as a smaller company with limited resources in terms of capabilities to build out kind of complex ETL processes, then it's kind of worked relatively well for us. So you can have a Lambda orchestrator or a direct processor essentially spawning off Lambdas to divide and conquer complex kind of ETL problems into smaller chunks. So for example, in our case, we get, as I mentioned, I think before, we get massive files from certain sources, including things like people data, company data. So you can actually, if you can split the file into maybe specific chunks and then use an orchestrator to kind of message various Lambda processors. So each Lambda is given a message saying, for example, well, here's the file I want you to process, and then it goes away and processes that file. You can do that again using SNS SQS, and then if the file processing fails to work, then again you make the most of having some of that message visibility window and dead letter queue to kind of indicate that you failed to process it. You could obviously store it in a database as well, but we found that works pretty well. And again, you kind of making the most of the elastic nature of Lambda processing. So you essentially scale ultimately almost infinitely. Just got to be quite aware of costs, as I'll come on to the next slide. But it's a pretty good pattern. In this slide, you can see the ES sync notification. So this is an example of an event bus thing where the processor doesn't want to take care of perhaps updating Elasticsearch when it's writing to MongoDB. So by spawning off a separate message to a similar queue, it can kind of deal with that asynchronously. And again, following the reactive pattern, you want ultimately you want your processes to complete as quickly as possible and asynchronously as possible. So this kind of design pattern facilitate that. And again, you've got that fine-grained concurrency control, which you've mentioned, using some of the options around things like number of batches, visibility window, things like that, and that lets you optimize how much you essentially almost want to spend on scaling elastically. So you can provision a set number of Lambdas to work at once or not. I think we've even got one use case where we only allow one Lambda to process at a time, just to, we feel we don't need more than that, and it will just process messages as it comes across them. But again, that's maybe an extreme case. So finally, I wanted to talk about our experience as a kind of a retrospective on using AWS as a startup. We essentially built something from the ground up, from nothing. So our experience is AWS is essentially designed to accelerate your time to release. So, obviously the more off the shelf the service is, the more bells and whistles it has, then, for example, Fargate versus maybe spinning up your own EC2 cluster for containers, then the quicker it is to build, but typically more expensive. Initially, it's as we all know, very low cost and great for startups with little capital, because you start off, you pay as you go. You may perhaps make the most of some of the options around the free tier and so forth. So again, that helps a lot. Aspects of it can become comparatively expensive. So as I said, like some of the off-the-shelf products, even things like Lambda, can quickly become expensive if you not abuse it, but kind of use it more than perhaps would be reasonable. We've had examples, for example, where extensive use of Lambdas for things like the ETL example I showed earlier was comparatively expensive for what we're trying to achieve. So you do have to measure and evaluate your use case as you evolve, which I think as an agile company is something every company should always do. So don't let it stop you from using the services. Just plan, or be ready to perhaps rethink and re-architect and redesign some aspects of the solution once perhaps those costs become prohibitive and more than the cost of potentially rebuilding something a little bit more bespoke. So, for example, in our case, as I mentioned, the ETL solution, we're now, as we've grown as a business, become a little bit bigger. We've got the resources available to now start to think about, well, how about we re-architect an aspect of the solution in order to potentially save on some of those costs long term. There's always going to be that initial cost to build, but ultimately, if the long term costs are substantially cheaper, then it's something that's worth considering. So, my suggestion is that you always do start with serverless if you can. It just makes things so quick and easy and painless. You don't have sleepless nights worrying about, if your EC2 cluster has been patched with the latest Python version or security release and stuff like that. It certainly helped me, who was essentially having to manage most of this infrastructure myself, for long periods of time. Not now, thankfully, but having things serverless has meant we're not worried about a lot of that. So do start with serverless. Use tagging and other cost monitoring solutions to evaluate where you are, what costs money, where your spend is, and optimize for cost efficiency as you need to. Don't predict it. Don't go out your way in building a all singing, all dancing solution just because you think in the very long term it might save you some money. Follow the agile approach and just reevaluate at all time and evolve with AWS if you can. So yeah, it'll be really interesting to see what AWS announce in the next reInvent session that's coming out soon, but look forward to hearing all about that. And that's it for me. So I don't know if anyone's got any questions.
Yeah, thank you very much for that, Alex. So there is a question that's come in from Lee Jones, which is, why did you elect not to use SageMaker?
Ooh, good question. I'm not the data science expert, so apologies for my potential lack of knowledge here. So ultimately, I think it was, the how and the why of it, of the way it was trying to force our more, not the running or the training of the models, more the initial definition and experimentation of using models was different to the ways that our data scientists were used to and familiar with, and ultimately some of the services by Amazon are great, but they don't always provide that much value over and above what you're actually trying to achieve. So in our case, we elected not to use it. This is something we should probably we haven't looked at it for a while. Something we should probably look at again. But yeah, at the moment we're kind of happy with where we are at training on EC2s and a lot of the AI experimentation is happening more local on machines.
Another question here from Hugh, who's basically asking that you've mentioned Python and JavaScript, are there other languages? She was asking, and I guess the devs committing across the whole stack in terms of are you set up to be full stack?
That's a good question, and Smile. So we originally chose Python again. Being a fairly comparatively new company, essentially we're able to choose whichever languages we wanted. I think from a front end full stack point of view, I think TypeScript and JavaScript was fairly obvious no-brainer. Python we chose again, kind of ease of use, speed of building things. We all knew Python and JavaScript are fairly similar in that approach. That's quite high level, allows you to build and prototype things very quickly, and also especially on the platform side. So we currently have 3 teams, so platform engineering, data science, and product, who are like more the UX full stack engineers. And especially at the beginning, basically the platform engineers and data science was pretty much the same people to a large extent. So being able to, as we all know, like data science, most of them are using Python. So being able to use Python to do both data science and platform engineering was quite key for us. So those are the 2 main ones. We haven't really played around too much with other things. Obviously, there's some bespoke stuff like the YAML definition of serverless, some of the Terraform stuff in Terragrant. But yeah, Python and TypeScript are the main development languages.
Yeah, I think if people haven't seen, like the Datadog Data Serverless report came out a few weeks ago, and Python and Node were by far the 2 most popular languages when it came to Lambda. Yeah. And Python had actually significantly increased. I think it was about 59% of all enterprises use Python, the main programming language for Lambda functions, which is interesting.
Yeah.
So obviously conscious about time. If anyone does have any follow-ups, then feel free to get in contact with Ali. You've got your contact details up there, so we'll keep that up there. And I wanted to bring in.
Yeah.
I wanted to bring in Mobilize. So you very kindly sponsor the meetup. So I was hoping maybe you could tell us a little bit about Mobilize and then what you have to offer. And we'll do the and come off mute as well.
That old chestnut. Sorry about that, everybody. So diolch yn fawr, Aled, diddorol iawn. So just a little quick intro. It's been a while since we've all met up in person. I can't see who's on the call, and we'll go into that in a sec. So hello to everybody who knows me, and to those who don't, nice to meet you all virtually. So my name's Jim. I'm the CTO and founder of Mobilize. One thing I would call out on, it's great to hear you embracing serverless technology. That reminds us, Matt must do another serverless events someday when all this COVID nonsense is over. For managing serverless workloads, that presents its own challenge. We've adopted in Mobilize a tool called Epsagon, which we find really useful for managing and maintaining serverless workloads. So anybody who's considering serverless, have a look at that. It's until you hit the threshold of X, it's entirely free. So it gives you really good visualizations across a serverless stack. So Mobilize is an AWS advanced consulting partner. Have been since 2014. I won't go into the kind of selling you the dream about what we do. We run big digital transformation projects across government and finance sector and other sectors. But the reason why I'm here and talking, we've been working with Matt, sponsoring the South Wales user group since its inception. Usually when we meet up in person, we provide some pizza and beer and, allow everybody to have a chat and some food. Unfortunately, we can't do that because of the restrictions. So I thought we could give away some AWS exam vouchers. We've been recently, as part of the group, supporting the Get Certified Challenge. We've got some more exam vouchers to give away. It doesn't matter whether you're doing looking at the CP, an associate, a pro, or a specialty. I can get you vouchers for both. The plan originally was for me to kind of scrape all the attendees and do it on the fly and say I've randomly picked out two names, which are X and Y. Unfortunately, I can't see who's in attendance. So I think the only way we can do it is if I post my email into the chat. If anybody's interested in a voucher, if you want to email me, hang on a sec, is he talking and typing? If you want to email me, hopefully that appears. Just to say you'd like to be considered for the raffle, I'll pick out the names tomorrow and I'll get into contact with you. Just to reassure you, GDPR rules apply. This is for entirely the purposes of giving you some free vouchers. We will not put any of your email addresses onto some marketing list, and you won't be contacted by any of my sales guys trying to sell you something. If you want to put in your email, you're interested in hearing more about Mobilize, obviously we'll tell you about it. But for the purposes of giving away the vouchers, if you can just email me. I don't know whether my my email address appeared in the comments there, Matt. You able to just check my email address in the comments? james.carney@mobilize.cloud. So if you would like to be considered for a voucher, drop me an email. I'll look at them later this evening, pick out a winner and get in contact with you tomorrow, and we can assign you a voucher. The vouchers are valid for 12 months. It doesn't matter if you're looking to sit an exam within the next X amount of weeks. You can sit on that voucher and use it within the next 12 months. I'll assign it to your email address. Thank you very much.
That's fantastic. So thank you very much, Jim, and to Mobilize Cloud for doing that. Thank you to Aled for giving us that insight into Selligence and sorts of services and challenges. So with that, obviously, please get in touch. We've put links to the Discord channel at the top of the chat. And stay safe, and hopefully we'll meet up soon, focusing both on some of the key findings and things that have come out of reInvent next week, and then also we'll continue to run some sort of certification workshops as well. So take care, everyone, and hopefully we'll meet up soon.
Cheers.
Thank you. Thanks for listening.